Okay, cool. I think we'll go ahead and get started here. First of all, thanks for coming to my talk about views and touches on Android, and now going to Jesse's talk instead. Definitely would be there instead if I wasn't giving this talk here. My name is Caren, and I'm currently working as an Android engineer at a company called June. So I kind of got the idea for this talk a couple months ago when I was working a lot with custom views and touches. And as a typical engineer, I was just trying to write as much code as possible, trying to do things that I thought Android should be doing, and that would never end up being the case when I'm handling touches myself. So it just ended up being this really complicated process with a lot of headaches and pains. So I thought I could give this talk so that other people who wanted to work more with custom views and touches in the future wouldn't have to face the same kind of pains. So when I first started developing for Android, one of the first things I learned was setting an on-click listener, right? So you set an on-click listener, and somehow Android will magically handle it for you and do whatever you want it to do. And then things got a little more complicated, and I learned about a long-click listener. So you can set an on-click listener and a click listener on the same view, and somehow Android would just know, okay, this is what I should do when it's a click, and this is what I should do when it's a long click. But how do these APIs really work? I didn't really know. I didn't think I'd have to care about it until the day when design asked for something a little more complicated, right? So how many people here have actually written custom views for their apps? Okay, cool. Almost everybody. So that's pretty cool. So the motivation for me, as I mentioned before, was that I'm currently working as an Android engineer at a place called June. So June makes smart ovens, and as you see on the right-hand side of the oven, there's a touch screen, and that's actually just a screen for a Nexus 5. So everything I'm doing is work on what you see on that screen. So it turned out that writing UI for an oven is a lot different than writing UI for a phone for some more psychology reasons about how people interact with appliances as opposed to their phones. So we didn't want people to feel like they were using a phone, or we didn't want people to feel like we just put a phone in their oven. So we wanted to write a completely new UI for all the views, all the recycler views, so nothing can be seen as just a phone. And it turned out that people actually would perform clicks a little bit differently than on their phone, because they would think that they would have to press a little harder if it's an oven as opposed to a phone. And also, the oven is usually at waist length, so when you're interacting with it, you're kind of going like this, as opposed to when you're using your phone, you're kind of going like this. So there was a lot of angling problems with what constituted as a touch, and which is why we had to rewrite a lot of things. But that's all cool, but nobody else here is, or probably nobody else here is going to be writing UI for an oven, right? So why should you really care about this? So it's actually good to learn how touches and views work under the hood, because then you could customize for behaviors that you want and create better user experiences. And also, just kind of knowing how things work helps you become less stressed when you're creating new features or debugging. So we're going to jump right into kind of what happens when a user touches a screen, right? So when you interact with your screen, the first thing you do is you kind of put your finger down on the screen, you touch a screen, you maybe move around a little bit, and then you lift your finger, right? So the way that Android thinks about all this is through something called a motion event. So every time you interact with the screen, Android gives you a motion event. So a motion event has something called an action code and axis values. An action code is just moving up and down or moving your finger around the screen. And axis values is just where the position you touched on the screen is. So if we think about it in terms of Android, touching the screen is just an action down, moving around is an action move, and lifting your finger would be an action up. So if we take a look at this example here, if the blue view is our screen and the red dot is where we touched it, and when we touch the screen we would get a motion event, and when we call the motion event for the action we get an action down, and you could get the X and Y values for it. So now that we know a little bit about what happens when you touch the screen, next thing to kind of look at is how views are laid out on the screen itself. So if we look at this view as what the screen is, it's actually a little bit not intuitive, because it's not like a regular XY axis. The top left corner is actually 0, 0, and then you get to the bottom right corner where it's max X and max Y. So if you have a screen, or if you add a view to the screen like this, all you really know about the view there is the top left corner and the width and the height of the view. So when you touch the screen, what happens is the screen receives this touch event, which is a motion event, and using the XY coordinate, the motion event is sent to the right child views. And then the view can decide whether or not it wants to handle the motion event. So the main method that we kind of care about right now is the onTouchEvent, because we're just worrying about what happens when the user actually touches. So we have this onTouchEvent that returns a boolean, and it returns true if the view handles the event, otherwise it's going to return false. And some people are looking like this right now, like what's going on? So it's a little bit more clear if we jump into some code. So if we did implement our custom view class, it would look something like this, where we extend the view class, and then we could override the onTouchEvent so that whenever a new motion event comes, we could examine what kind of action we got and handle it appropriately. So here we're not really doing anything, we're just logging some events to see what happens. So we don't want to say, okay, we handled this event, so we're returning false. So this is just like a very basic example of how you would create a custom view and then handle your own touch events. So if we take a look at that and then expand it a little bit more, we could see, okay, what does it really mean to click on something or long click on something? So if we think about it, it's all really just about like how long it takes from the first down event to when you lift up your finger to the last up event, right? So then if we want to handle something like this, we could just look at the up event because that's all what we really care about. And once we do realize that the user has lifted their finger, we could calculate the time of when the last or the first down event was till when we lifted up our finger. And using that, we could kind of determine how we want to handle it, whether it's a click or a long click, or if we just don't want to handle it at all. So this is like a very basic example of how I think, or actually Android does a ton of handling under the hood, but if you wanted a very simple example of how clicks and long clicks are handled, this is probably it. Okay, so that's great. Like we created all this and we know if it's a click or a long click, but the problem is we're not telling Android that we actually want to handle these motion events, right? So this view is not saying, okay, I'm actually interested in handling these events. So what we have to do here is we have to override the onTouchEvent to return true. What this means is, okay, I actually want to handle these events, so actually give me these events and I'm actually going to tell you that I did something with it. But actually, no, this is not what you want. So this is something I did when I was writing my own code. I was like, okay, I wrote a view. I want to tell Android that I want to handle this myself, so return true. But what this does is it ends up handling every single event that comes to your screen, which is bad, right? Because there's all these other views on your screen that should handle it accordingly. So we don't want to do that. Something a little bit better here would be if we return whether or not the touch that we got was actually in the view. So we could go in a little deeper and see how this is implemented. So the good thing is we also have this method called getLocationOnScreen, which returns to you whether or not or where the view is as opposed to the screen. So using that, we can get the location of the view, and using that, we can determine, is this motion event within the view that we're looking at? But actually, no, this is actually also wrong. So this is something else that I faced, because what you actually want is you want to get the raw x and y coordinates of the event and not just the x and y regular x and y coordinates. And the reason for that is because every time these motion events are passed down from view to view, it gets translated as according to the view it's in. So if you just do get x and get y, it's going to be the x and y according to that viewing, not according to the whole screen. So now that we've handled all of that, in the end we would just do something like, if it's an action up event and the touch was in the view, then let's handle it the way we want it to. So this is like all good, but we already have an on-click listener, right? So why would you want to go through all this work doing all this stuff? Well, a better example might be where you swipe down to dismiss certain views. So a lot of apps have things where you go into a detail view and then you swipe down on the detail view to exit it. So let's take a look at how we can implement that with what we did with the on-click listener. So the main thing about when you're swiping down is we want to see where the user started on the screen and where the finger ended up before they lifted or where the finger lifts up before they stopped interacting with the screen. So the first thing we care about is when they put their finger down, and we kind of want to record that and then use that to determine when they lifted their finger if it was actually a swipe down as opposed to swiping left or right or up. So using that, we could say, okay, when they lifted the finger, was the last y coordinate actually bigger than this predefined range that we set? And if it was, then we could start an animation to slide the view down. And then we have to return true to tell Android that, okay, yeah, this view handled this event. And now people are kind of like, okay, I just don't want to do any of this anymore. But it actually gets a lot more complicated than this, because why have we even been doing any of this of making our own custom views, right? Like all we did was handle the onTouchEvent. So we could have just did an onTouch listener and do the exact same thing without having to go through the trouble of creating our own views. But like while this is great where you can just set an on-touch listener, we actually get a lot more if we extend views and create our own custom views. So when we extend our own views and create our custom views, we get extra methods such as this. So there's actually an extra method called dispatchTouchEvent, which passes the motion event to the view that's interested, and it returns true if it's handled by the current view and false otherwise. And it can kind of be used to like listen to events and do stuff accordingly, which sounds really abstract right now, but there will be examples of this. And specific to view groups, there's an onInterceptTouchEvent, which is called also when touch events are passed around. But this method is only specific to stuff such as like recycler views or frame layouts. So if we take a closer look at this example, this is something that's like really common. You have a frame layout and then you put a button on it and it looks something like this. But when you lay out the activity tree or the view tree, it looks something like this where the activity is on top and then you have the frame layout and then you have a button. So for every motion event, we kind of examine how it gets passed through from view to view, right? So dispatchTouchEvent will be called on the activity, and then it will be passed down until some view decides, okay, I want to handle it. So the button would not, so if we say that the frame layout actually wants to handle this event, and we return true on dispatchTouchEvent, then the button actually would not call dispatchTouchEvent. Instead, onTouchEvent for the frame layout would be called, which is a little complicated, but if the dispatchTouchEvent gets to the button, so there's no more views, now it means like it has to handle it, then the button onTouchEvent would be called. And similarly, it's going to get onTouchEvent will be passed up through the view tree until someone handles it. So this is all kind of crazy. So I tried to create this graph, which looks really crazy, but if you just kind of follow it, so if the activity's dispatchTouchEvent returns false, then we just keep going down. If it returns true, then whichever dispatchTouchEvent returns true, onTouchEvent will be called for the same view in which dispatchTouchEvent returned true. And if you notice on the bottom, when you get to dispatchTouchEvent for frame layout, you actually end up on the onTouchEvent for a button, and that's because it's the last view that could possibly handle it. So the button doesn't call the button calls onTouchEvent before dispatchTouchEvent because it doesn't have anything to dispatch it to if it's going to handle it, right? So similarly for the onTouchEvent, if the dispatchTouchEvent for the button is false, then you go up to the onTouchEvent for the frame layout until someone decides they want to handle it, right? And the way the chain kind of stops is when something returns true, then the chain of events kind of stop there. So this is all like super complicated. I must have read through like the docs like 10 times and still didn't really get it. So I created a GitHub project that kind of has something like this, where I created my own view class and my own recycler view class, and it has these log statements that I could see. So every time I touch on a view, I could see exactly like what's happening, which calls are being made first. And this is how I really got the hang of all this. So if you're really interested in how all this works, definitely check out the GitHub project. Everything is already done for you, so you just have to build it and then do some touches for yourself and see how things are working. And another thing that I found really helpful was instead of returning like super.dispatchTouchEvent, I would just return true and see how that affected everything else, or I would return false and see how that affected everything else. So this is all good, but like this is really complicated, so when would you actually use something like this, right? So here are some examples from what we did in the oven. So this is a screen taken directly from the oven. So the oven obviously cooks food, so you can select what kind of food you want to cook. And if you notice for this screen here, we did something special where there's actually no long click listener. So you can click for as long as you want. It will just register as a regular click. And also you can kind of move your finger around on the same screen, and we don't cancel your click until you start scrolling. But if you notice, like the event is actually being handled by the item in the recycler view first, but then when you start scrolling, it's getting passed to the recycler view itself. And a little bit more complicated example is this, in which, I don't know if you get, so you can kind of see on the bottom where it's a little bit translucent. If you see the bottom, like baked goods right now is a little bit like faded out, and that's because we have a custom translucent bar on the bottom. So the special thing about this is that you can't click on that translucent bar, but at the same time, we want to start scrolling if you started scrolling from the bottom, right? So what we had to do here was something a little hacky, where if we started moving, we had to see if the touch started on the bottom view, and if it did, we actually send that event to the recycler view and dispatch it accordingly, so that we always capture your scroll events, but at the same time, we don't capture your click events if you end up on the same spot. So this is kind of the stuff that I worked on to get a hang of all of this. Now you're just really like, okay, I'm never going to do anything like that. Like, what are you talking about? But if you did want to pursue more in this, there are a lot of things to consider when you want to customize your own behavior. So the first thing is, this is obviously very complicated. There's a ton to handle. So you can actually just, a lot of things like single tap and double tap are all handled for you with a gesture detector. So you don't have to extend anything if you just want to handle simple stuff like scrolling or flicking or touching certain views. Another thing to consider is the view configuration class that Android provides for us. So this gives you a lot of constants that are very similar in Android. So Android has already defined like how long a tap should be or how much the user's finger can move before it's considered a scroll. So if you're like defining for your own views, you want to kind of be similar to what Android uses so the behavior doesn't differ too much. Another thing to consider is while it's great that we're always thinking that the user is only using one finger on their screen, many times they could have like multiple fingers on their screen, right? So every individual finger will add an extra variable that's identified by an ID and index. So we were using a lot of getAction before our MotionEvents, but that's actually not very foolproof. We want to use something called getActionMask, which gives us exactly what happened on each pointer. And there's a ton more about multi-touch. If you want to look it up, definitely read the documentations for that. So in summary, TouchEvent handling is really complicated. So you always want to use something like GestureDetector or Gesture Listener if you can. But on the other hand, all touch events in Android are packaged into a motion event that you can handle if you want. And it's passed down until a view decides to handle it, which we'll call the onTouchEvent. And events can be intercepted and redirected as needed. So there's a ton more great talks that go a lot more deeper into what I just talked about. So if you really want to write custom views, one to check out is Writing Custom Views by Adam and Romain Guy. And if you want to like learn how views are measured and laid out, or the whole process of how it works, there's a great talk called Measure, Layout, and Draw. And two other talks that are very similar to what I just talked about is one from Felipe and one from Dave about making sense of a touch system and how it works. And yeah, so everything that I just talked about is going to be on Twitter, and also all the code examples are going to be on GitHub if you're interested. And yeah, I'll take some questions if there are any. Is that a question or?
Did you set up the nearby beacon? What's that slide show somehow?
The nearby. So he asked if I set it up a nearby beacon. I don't know what that means.
Okay, I just got a notification about that slide. How did you do that?
Magic. Cool. Yeah. Oh yeah.
How do you like the oven?
The oven is amazing. Yeah, so I didn't talk too much about the oven, but if you're interested more about the oven, I'm definitely open to talk about it. It cooks food for you. I never used to cook before, but now I can make my own food every day, and it turns out amazing. And I have discount codes if you're all interested. Yeah?
So besides the custom touch events, is there anything else that you found was kind of different when designing for something like an oven rather than phone?
Yeah, so the question was whether I found anything different about designing for an oven as opposed to a phone. I think the thing about oven is the user interacts with it as if it's an appliance. So they don't think of it as a touchscreen. So we have to think a lot about, okay, just because there's a back button on like the phone, that's not something we would want the same behavior on an oven. And scrolling on an oven is actually a lot different on a phone as well, because you're kind of like going at an angle like this. So the amount of your finger that touches the oven screen is a lot different than the amount of finger that touches your phone. So like just stuff like that where we had to customize a lot of those behaviors and make things like a lot bigger as opposed to a regular phone was a little different. Is there any other questions? Great, well, thanks again. Oh, sorry. Yeah.
Okay, no, I'm just going to talk to you probably about this because it's probably long.
Okay, great. Yeah, thank you again.